there is a requirement for a new set of sensor form factors in the smart building. So the concept is you have something that's as easy to install as a piece of tape, but is incredibly high precision. Most of our customers would call this a smart tape. It is in fact a printed resistive sensor. We don't just have one sensor, we have 12 sensors, and we can start to use those together as a model for understanding a leak event.
Good morning to this week's ipXperience in the world famous IP Exchange Studios. Today, not quite sure what we're going to talk about, but Matt from LAIIER absolutely knows what we're talking about because he's got a new kind of technology that will help you do sensing in smart cities. He's going to be much better at talking about it than me. The reason why I'm not sure isn't because I'm not very bright, although anybody who follows this channel knows that I'm not very bright, and the person on the other end of the screen is much brighter than me, is because he's changing the world with what he's doing. So over to Matt from LAIIER. Just give us a brief introduction as to what you're doing with your innovative technology.
Awesome. Thank you so much, Guy. Yeah, my name is Matt Johnson, CEO and co-founder of LAIIER. LAIIER is a startup based in London. We are a continuous monitoring solution for smart buildings. And the first use case for us is escape of water. So that's when water is coming out of a piece of building equipment or out of a pipe where it shouldn't be. And the reason we're interested in solving that is that it's an insanely expensive problem. In the UK alone, it's around £1 billion a year in insurance claims for escape of water in buildings. And we're really focused on commercial buildings because there's exceptional risk to water leaking and damaging the building and interrupting business operations. And we have a very unique sensor form factor to monitor for that, which is what I'm excited to talk to you about.
Okay. Tell us about this sensing form factor then.
Okay, so I'm very happy to. So I have a background in printed electronics, and so excuse me if I geek out a bit about how interesting the printed electronics field is. We believe that there is a requirement for a new set of sensor form factors in the smart building, simply because most of the problems in a smart building require you to monitor a large physical area with a very high precision, but you have to be able to do that at a cost that the use case can afford. So it has to be cost effective. And there are very few technologies that can do all three of those things, right? You have some technologies which can monitor a big area with high resolution, but it's really expensive, or you have technologies that can cover a big area with low resolution and it's pretty cheap. We think that printed electronics allows us to kind of break that cycle and optimize for all three. And for us, the first product in that space is this printed tape. So I would say that most of our customers would call this a smart tape. It is in fact a printed resistive sensor. So this one's about 1 meter long. What we have is a PET substrate. So it's a PET film with conductive inks and insulating inks or dielectric inks printed on one side, and then it's self-adhesive on the back, so it's sticky like tape. Yeah. That tape is then connected to a hardware module, which is battery powered and transmits data via LoRaWAN. So the concept is you have something that's as easy to install as a piece of tape, but is incredibly high precision. So that's the umbrella idea.
Okay, I get that. Very clever. Is that energy harvesting, that battery, or is it reliant on?
No, it relies on a specific chemistry, but it is a AA cell. So right. We use a 3.6 volt AA cell. Yeah.
Okay. So you describe. I mean, obviously, buildings have pipes. There are tens of thousands of cities in the world. I don't know how many pipes. Billions and billions and billions of miles of pipes, all potentially ready to leak and cause huge amounts of damage. So how if you've got a building that's 80 stories high, pipes going all around it, water going all around the building, and I understand, I clearly identify the problem that you're solving, but how does your tape, I mean, you can only put your tape in one place. So how do you identify?
Yeah. Where do you put it? Yeah. Is that the question? Yeah. So
yes.
I would.
Best.
Yeah.
Thank you for succinctly getting the question.
Where do you put it?
I struggle to get.
Well, it's interesting so I have a customer install this afternoon, And I'm sure that there will be a facilities management person there, and I'm sure that there will also be somebody from the business who's not in facilities management. And I'm sure the person who is not in facilities management will ask that question, where are we going to put this thing? And the facilities person will say, I know exactly where to put it. It's totally obvious. And the reason that they know where to put it is because we either want to monitor places where leaks are likely or leaks are expensive. And so a place where leaks are likely could be bathrooms. Toilets are notorious for leaking. It could be air chillers. So the HVAC system often has leak problems. Condensate drains are frequent culprits for leaks. Or we could put it somewhere where it's expensive, like a server room. So when I say expensive, if we get a leak in the server room, that could be a really expensive problem. And so right now we're deploying a tape that's 1 meter long. So, we can cover a reasonable surface area, much more surface area than many competitive products. But the nature of the printing technology is that this tape will get longer and longer and longer without increasing the cost dramatically. So the length, it'll get longer faster than it gets more expensive. And that then allows us to cover more and more area.
Right. So I understand now. So obviously, just to use an analogy, if you are, it's like the Malcolm Gladwell thing with crime, with his tipping point analogy, which is actually you always know where the crime's taking place. You don't need policemen everywhere. You just need them in the one place where we know crime always takes place. So you can clearly identify where there's likely to be a problem. Okay. So what is the tape and the sensor actually doing? Is it sensing everything around it, or is it sensing just the pipe itself?
Great question. So the function of this sensor is as a resistive sensor. So in principle, it's quite a simple idea, which is that you have a circuit printed on the tape with conductive ink. When we have a bit of water contact it, it then changes the voltage drop across the circuit, and we measure it. And so we need contact with a conductive liquid, so in this case, water. And we have quite a lot of resolution available to understand how much water is present on the tape. So we are as sensitive as 2 drops of water, or 0.1 milliliters of water. So that's an incredibly small amount. And we can then detect all the way up until this is completely flooded. One of the key USPs of what we're doing is that we have this repeated pattern. So in fact, each of these boxes is its own electrode. And so when we have a strip of tape, we don't just have one sensor, we have 12 sensors, and we can start to use those together as a model for understanding a leak event. An example of that would be a leak which is a kind of dripping leak from a condensate drain. So it's not important to action a repair right now, but it's important to know that it's there to put it on the list. Yeah, exactly. Or you could have something where suddenly 1 meter of tape is covered with water in 1 minute. Okay, that's a serious issue you need to go look at right now, because that could be that somebody broke the toilet off the wall, or the tap has broken on the sink and there's water flooding the floor. And so being able to differentiate between those events is really important and super unique in the market.
Right. And I take it that's proprietary software that you've written and invented.
Yeah, so we have a number of patents around the device, and one of them covers the concept of using multiple printed electrodes to generate different events.
Right. So when a customer buys into they're buying obviously into the tape, but what they're actually buying into is the cleverness of the software that's identifying the different, or you work with them to say, what is the point at which you want an alarm?
Yeah, exactly. Because that actually is, you're totally right. It's not being pedantic, but it's a subtly different thing that customers value. So they value differentiating between a little leak and a big leak, or a slow leak and a fast leak. But for what you said, at which point they want an alarm, I would say is the false positive rate. So Nothing drives facilities people more crazy than sensors which go off when there's not actually an event, you know. And it's, for me, it's easy to have empathy for that, right? You know, you might a guy manages a 20-story building and you have 3 alarms and you're going up and down the lifts, you're running up and down the stairs, and every time you get there, it's not a real event. Eventually you're just going to sit in the basement and say, yeah, I'm just going to read the news and ignore this stuff.
Yeah.
So we have the ability to create rules which might say something like, in the server room, if we sense water on any one of these electrodes, we should send an alarm, because there should never, ever be water in our server room. However, we might have a shower area as part of a gym in the office, and there we expect that it's going to be wet. So we might say, look, if 5 of these are wet, or if 5 adjacent electrodes are wet, then we should send an alarm. Otherwise, we'll just send a regular message every 4 hours with a status update. And so customers love the ability to use the same hardware in different contexts with different sensitivity.
Okay, so at ipXchange, we're all about disruptive technology. So you're describing a completely new invention, new way of doing it, your subtlety. I love the way that you called it false positive. I bet anybody who's listening to this had ever come across the phrase false positive before COVID. I certainly hadn't come across false positive before COVID. Maybe that's just me. So always we have to talk about how would you solve this problem if you didn't exist?
Well, so customers are choosing between 3 different technical solutions that can be provided by a bunch of different companies. So, you know, I will put myself in the position of a facilities manager who wants to monitor their space for leaks. And the first way that you might do it is with what is called a flood sensor or a spot sensor, which is something you could buy off of Amazon. Typically, they're like a little white disc that you might put underneath the dishwasher. Those are low cost, they have long battery life. Some of them have wireless connectivity, some of them just beep. And the advantage is super easy to install in general, but the disadvantage is that they cover very small surface area. So we have seen numerous photos from insurers where there is practically a river inside of a building, and right next to it is a perfectly dry sensor.
Yes.
And yeah, and people will add, companies have added humidity sensors to try to detect changes in humidity to make the models more robust. So if it's immediately adjacent to a river, we should expect some change in humidity. That's not a totally reliable mechanism. But so spot sensor or flood sensor is the first. The second would be a rope sensor. So they're a little bit more exotic, but they're used very widely in data centers. So small plastic box with what looks like a nylon rope attached to it. And people really like those because you can run 10 meters of rope around a room, and they can be useful in detecting early leaks. The challenges that they are typically say that you need 3 to 5 millimeters of standing water on the floor before it will detect, which is, depending on the configuration of the room, can be quite a lot of water.
That's a crisis.
Right?
That's a
yeah,
crisis.
Exactly. So that could be a lot. But then additionally, what we hear over and over is that the practical use of the rope can be frustrating because of the fact that it's hard to install, so it doesn't sit flat. So we've talked to lots of people who use like cable tie mounts stuck to the ground, and then they cable tie the rope to the cable tie mount, which is just so frustrating. And the other thing about the rope that we heard is that it saturates and doesn't dry out. So you might have a relatively small event, which you go and clean up, but the sensor is still detecting it because the thing is still wet, and it takes a really long, like days, for it to dry out. So the fact that we can reset quickly is interesting. I think the other thing, which is not trivial, is putting that rope behind 10 meters of servers is useful unless unless you really start to consider what happens when you get an alarm which doesn't locate that leak event along those 10 meters. That can become really frustrating. Yes, it's good to know that somewhere in here there's a problem, but actually, practically speaking, it's very challenging to then identify it because you start to have to remove so much equipment. So I think customers really appreciate the ability to locate a leak. It's here or it's here. And the last thing is an inline sensor. So that's something where you would cut a pipe or at least modify a pipe somehow to put a sensor inline, so a flow sensor. They can be very sensitive. And a lot of companies claim to use AI to detect a normal usage pattern and then will alert to any deviation. So a simple example would be, hey, suddenly tonight, in the middle of the night, we're using a bunch of water. We've never done that before. That's probably an issue, right? It's unlikely that someone's just running the tap in the office intentionally. The challenge with those, though, is that they're expensive to install because you're dealing with plumbing, but they also don't locate the leak very effectively unless you employ lots of them, which you wouldn't do because they're expensive. And so, I've talked to some facilities managers who say, yeah, flow sensors seem useful and then are really frustrating when they tell you somewhere in this network of pipes across these 3 floors, there's a significant leak. It just turns into a terrible game. But I think the last solution that we should never discount is somebody walking around. So in a lot of use cases, we see people are still doing a lot of manual inspection. So, especially for large flat roofs, once every 2 weeks or after a significant rain event, my job is to walk around and look at everything. And that just doesn't scale.
No.
So, yeah, that's the way people try to solve it today.
Yeah, and it probably doesn't solve the problem anyway, because you can have a leak that's flooding. It looks perfectly normal, and then 3 weeks later, the roof falls down. So,
yep, exactly.
Okay, good. So, I'll just ask one more question because,
of course,
you've obviously invented something quite clever. The whole idea that you've got this subtlety in the sensing. You talk about it becoming, you won't necessarily extend the price because you're going to get to a price sensitive point. At the moment, you sense water. Is this applicable in the, do you have in mind that this will be applicable to other things other than water, or is water always going to be the thing that you sense?
Well, so we can already sense things that are things other than water. So we can sense anything that's aqueous. So, food products we could sense if we thought there was a use case there, like ketchup, let's say. But we can also, with a different sensing mechanism, sense things that are not electrically conductive. So like hydrocarbons. So that would be oils. So from olive oil to motor oil. And we see that there are similar dynamics, so there to the market. So there are, or I should say to the use case, where you have places where a leak is almost inevitable, but you're not sure where the leak will be. It's then very expensive. So a lot of people immediately go to oil pipelines. That's not a market for us because of the physical scale, but there are some really interesting use cases that are within facilities to monitor for leaks.
Industrial manufacturing.
Yeah, exactly. And again, it's the same core problem. You know it's going to happen somewhere in here. You're not sure where, and you want to find it as fast as you possibly can, or as early in the process as you possibly can.
Okay, very good. So we started this phone call with me not really understanding, but we start most of these IP experiences with me not understanding what the person on the other end of the call is. But that's the whole point of having them on the other end of the call, so they can evangelize about their technology to our community. So tell me, if one of our community says, "Oh, that this looks like something I'll be very interested in," how easy is it to get an evaluation?
Sure.
Kit, and to play with it and see how it works?
Yeah, so we have a couple of different ways you can engage with the product. So we have evaluation kits which spit data out via USB serial. So it's a very simple format. So that's perfect for evaluating a new use case. So let's say you wanted to test if it worked on a food product, if you're as part of a production line, That's a really easy way to do that. So those are available and you can contact us. We then have the ability to sell just the individual pieces of wireless hardware. So that's LoRaWAN hardware. So it requires somebody who has a LoRa network, who understands the protocol. We also have an out-of-the-box package, which includes multiple sensors and a gateway, which is appropriate for doing a test where, let's say you wanted to monitor for leaks in your production facility and you really just want the sensors and a dashboard. So we can, and we can kind of mix and match between those depending on the customer requirement.
Right, excellent, good. Well, I think you've given us some excellent background about the technology that they're doing, sort of the new approach, the subtlety, the cost, and the whole software that sits behind it, so that you can have that level of subtlety and understand when there's a true crisis and when there actually isn't too much of a crisis. So I think from our community's point of view, we've covered everything off, and it's been very enjoyable. ipXperience. Thank you very much. If you wish to evaluate Matt's technology, we're going to put on. I do this quite often. I'm supposed to be relatively good at this now, but anyway, there you go. We will put you on our website, which is ipXperience.tech, where you can have a look at the written word, and then we'll give you the opportunity to fill out a form and get in touch with Matt. But for now, Matt, thank you very much. Very enjoyable video. And we look forward to updates about technology and maybe other things that you're doing, so we can tell our community about new ways that you're applying your very interesting approach. Thank you.
Thank you too, Guy. Great to talk to you.